Hey everybody, this is the first of several videos for day 8 where we'll be talking about sets. In these first few videos, I'm going to informally introduce the notation and operations we're going to want to use for sets, and then the rest of the videos will be about the actual implementations of sets that we'll be making in Coq. Let's get started. So, what is a set? A set is a collection of distinct elements. So in this video, I want to introduce just a little bit of notation for how we name these collections and give a couple of examples. Okay, so let's get started. The first set of examples is Coq types are sets. Okay, so what do I mean by that? So here's one. Bool is equal to the set true, comma, false. Okay, let's make some notational notes. So a set has a curly brace, elements with commas, and then another curly brace. This is the notation for writing down a concrete set. So bool is one such set. Let's look at another. Another one from Coq might be day, where we have Monday, Tuesday, Wednesday, Thursday. All right, little Rebecca Black moment. Friday. Oops, not Saturday. Saturday. Sunday. Right, that's another Coq type. But there's other Coq types that can show up there. So nat, well, this one's going to be hard for me to write down all the way. Right, so 0, 1, 2, 3. You'll notice I'm using the Arabic numerals just because I feel like that's more convenient. I could have also written O, S of O, S of O, S of S of S of O. Right? And you notice I have this kind of imprecise ... These sets, let me get my cosmic pen going, are infinite. Right? So I'm not going to try to write down all the naturals because this video would just be way too long. There's too many of them. Okay, one last Coq type that's also a set. So if A and B are sets, A arrow B is the set of functions that take elements of A, right, the things that are in A, and return elements of B. Now this set is actually even harder to write down than nat for reasons we'll discover in like 10 weeks. But these are all perfectly good sets to talk about. Now, these sets are finite, and we can write them down. These sets, oh, sorry, that is an ambiguous curly. Let me fix that. These sets are finite. These sets are infinite. Generally speaking, you can come up with finite function spaces, but let's leave that alone. Okay, there are other sets. So let's look at some. That's the notation for the empty set. A really common sort of mistake that students make is that they'll write things like that to mean the empty set, and I want to say, please do not. Just say no to funny notations for the empty set. If you want to write it, it's a circle with a slash through it. That's how you do it. Okay, so that's one worth talking about. Here's another set that's not a Coq type, but we could make a Coq type. I like to call this set RPS, and it's really good for examples because it's got 3 elements, which is like small enough to be easy to work with, but bigger than the Boolean, so like not necessarily as trivial. And this is the rock, paper, scissors set. I really like working with this one. I think it's really helpful for thinking about simple examples. And then when you get bored, you can play your friends. I guess it's kind of hard to do rock, paper, scissors over Zoom. It's like too easy to cheat the time. Like, oh, my internet went out. It's a likely story. but another set that we could talk about. So a good exercise also is to think, how might you define this RPS set in Coq, right? It's sort of like an easy kind of quiz / midterm question I could ask. Okay, so I want to add one last thing. I want to give some non-examples. What are some non-sets? Okay, what makes something not a set? Well, it has to be a collection of distinct things. So like here's one. Excuse me. Thank you. I'll keep writing it in red just to make it clear that these are wrong. Here's one. True, false, true. This is not a set. Why? Well, you can't do this guy twice. Right? Each thing in a set should only occur once. What else might not be a set? Well, we could say it's, oops. The natural 0, 1, 2. And then I have all of those plus also true. That's a set. We're still good. And then we're going to add 1 in again. Okay, now we're no good. You can't have 1 twice. So the key rule here is no duplicates. Distinct elements only. And that's really the only constraint that we'll bother ourselves with for now. Okay, so this is an introduction to the various notational bits for sets. We've given some examples. We've seen that you use curly braces. Right, these curly braces, you use these to talk about the elements of a set. Some of our set definitions were a little bit informal, right? The nats, for example, I use that ... to be like, yeah, you know what I'm saying, which doesn't in general fly, but is good enough here. And then we saw a way to make something not a set, which is to have duplicates. Lastly, and most importantly, we saw the right notation for the empty set, which is that circle with a slash through it. I really don't want to see this like open bracket, close bracket notation for empty sets. It's just not right. It looks really funny. Okay, in some upcoming videos, I'm going to talk 2 more informal videos, one about predicates on sets, and then one about the operations on sets that we'll be implementing. Both of these are just going to be a small sampling of the things you could want to do with sets, but they'll sort of cover our bases for the actual work we'll be doing in Coq. Okay, talk to y'all soon.